All right, good morning, everyone. I'm going to do a couple of videos here about some of the homework questions from last week that got sent in, and hopefully this will help you. So this is a question about the viewing angle, and so you have a nice picture over here about your screen and the different kinds of things that are going on, and the ultimate question is we want to maximize this viewing angle, which is labeled in the picture as angle theta. And so we need to write a formula for angle theta. So I'm going to come over here to the whiteboard and see if we can't use some trigonometry and have x as the input variable, as the distance away, and theta as being the output variable. If we could write theta as a function of x, then we'd be able to take the derivative and do the optimization for the maximum. So let's see. We have this two triangles here that are kind of coming down like this, where this side we know is 3, this over here is 11, so that the total side over here is 14. And this is x, and this is our angle theta. So let's see, first I'm going to put this angle in here as alpha, and so the tangent of alpha is 3 over x. And let's see, what else can I do? I could think about doing like if I could have a law of sines or a law of cosines or something like that. I might be able to figure out the other two sides of the triangle and use something like the law of cosines to maximize this angle theta. Or I could do something about the tangent of alpha plus theta is 14 over x. So this gives me a relationship between alpha and theta and x. And if I could somehow get rid of the alpha in here, then I'd have my relationship between theta and x. So I'm going to look for the double angle or the sum angle formulas for a tangent. So I don't know, I don't remember exactly what that formula is, so I'm just going to look it up. Sum formula for tangent. All right, so here we go. Tangent of alpha plus beta is tangent alpha plus tangent beta over 1 minus tangent alpha tangent beta. Not sure if that's going to help us or not, but I'm going to give it a shot. Okay, so I'm going to write this as tangent alpha plus tangent theta all over 1 minus tan alpha tan theta. And so that's going to equal 14 over x. So now I'm going to substitute in tan alpha. I know is 3 over x. So I'm going to everywhere there's a tan alpha, I'm going to substitute in 3 over x. So I'll write 3 over x plus tan alpha, tan theta, all over 1 minus 3 over x tan theta is equal to 14 over x. So now what my hope is to solve for tan theta and then do inverse tan in order to solve for theta as a function of x. And then I'll be able to apply calculus to find the maximum angle. So I'm going to multiply this 1 minus 3 over x tan theta over to the other side to get 3 over x plus tan theta is equal to 14 over x times 1 minus 3 over x tan theta. This might be totally different than what they tell you to do under the question help. And if you want, you could kind of walk your way through that and maybe find a different way that speaks to you more. Now I'm going to distribute the 14 over x. So I'll have 3 over x plus tan theta is equal to 14 over x minus 3 times 14 is what, 42 over x squared tan theta. Now, at this point, it might be best to multiply everything through by x squared just to get rid of all the fractions that are here. And you can do that because you know that x can't be 0. If x is 0, you're standing at the wall and you're looking straight up the wall. You won't be able to see the screen. So I'm going to multiply through by x squared and get 3x plus x squared. Hey, Brandon, I'm going through that number 36, tan theta. I'm recording this, so if you want, when I'm done recording this, you can go back and watch the video. So here I'm going to try to solve for tan theta and then isolate the to get theta as a function of x. So I'm going to bring the plus 42 tan theta over to the left-hand side, and I'm going to subtract 3x on both sides. So I'm going to write it up here, and then I'm going to go to a new screen, maybe wipe this out, and keep going. Hopefully I haven't made a mistake. So I have x squared plus 42 all that times tan theta on the left now. And on the right-hand side, I'm going to have 14x minus 3x, which is 11x. So maybe I won't wipe this out. Maybe I'll just use the eraser. Again, you can go back and kind of watch the replay of this after I publish it. I'll put it up on YouTube, and then you can just give you a link to it when the recording is done. So now I'm going to divide by x squared plus 42 and get theta is equal to 11 inverse tan of 11x over x squared plus 42. So now I'm going to take the derivative and set it equal to 0. Hey, Jarrett. I'm making this is problem 36 from last week's homework, and I'm recording this so you can publish. I'll publish it up on YouTube so you can see the beginning part if you want. But the whole idea was I used a sum angle for the tangent in order to, and then I got rid of the alpha angle, which is the bottom triangle, in order to get a relationship between theta and x. And this is what I got. And now I'm taking the derivative and going to set it equal to 0. So the derivative of arc tangent is 1 over 1 plus x squared. One over 1 plus x squared. So that's going to be 1 over 1 plus this whole thing squared, 11x over x squared plus 42. times the derivative of the inside function because of the chain rule. And now the derivative of the inside function is this quotient rule, 11x over x squared plus 42. And so the derivative of that, I got to take, let's see, the bottom times the derivative of the top. So it's x squared plus 42, whole thing times 11. And then minus the derivative of the bottom, which is 2x times the top, which is 11x. And all of that over the bottom squared. And I want to set this all equal to 0. So now I'm going to try to solve this beast, but actually I don't think it's going to be as hard as it looks, because this term over here is never going to be 0. This is some number squared, add 1 to it, it's positive, and 1 over a positive number is always a positive number. So this is never 0. And so if this product here is going to equal 0, then this second part has to equal 0. And again, the denominator is never 0. So if this fraction is going to equal 0, it's the numerator that has to equal 0. So I think I just have this quadratic, which is 11x squared plus 42 times 11, which is what, 462, minus 22x squared equals 0. And so that's negative 11x squared equals plus 462 equals 0, which I'll just move this to the other side. Instead of factoring, I'm just going to use the square root principle, divide both sides by 11. So 462 divided by 11 gets me back to the 42. X squared equals 42. And so x is equal to the square root of 42. And, you know, we should really check to make sure that this is a maximum, but minimum doesn't make sense because you could go as far away as you want and that viewing angle gets smaller and smaller and smaller. So I'm just going to run with this square root of 42 and put that in. They say an exact answer using radicals as needed. So I'll go square root of 42. And that's how you do question 36. Do you have any questions? Brandon, Jared, Jocelyn, I see you there. This is from last week, yes. All right, so again, I'm recording this on YouTube. I'm going to stop the recording and then we'll start a new one for the next problem, and we'll do at least one more.